Hello, my name is Emma Seiler. I apologize for my soft speaking. I accidentally opened the problem at 4:30 a.m. so I have to do it now, and everyone's asleep in the house, so I will be as clear as possible. For my problem, I chose problem number 2 to explain to you, in which we were trying to find the maximum speed a race car could have going around a curve of 250 meters radius wise. So when I came into this problem, we had the coefficient of static friction, we had the radius in meters, and we had the mass of the car from the earlier problem. I used 2 equations related to centripetal force and Newton's laws. I realized that first I had to find the normal force, since normal force equals the force of gravity in the situation, since there's no y-directional movement. So the normal force would equal the force of gravity opposite, and so I just found that, made it not negative, and plugged that into my force of friction equation, which is the force of friction equals the static friction coefficient times the normal force, and that got me about 9,437.4 newtons. I then plugged this equation into one of these centripetal force equations we were taught, which is force equals mass times velocity squared over radius. Velocity squared over radius being equivalent to acceleration. I decided that the frictional force would equal the force applied, since static friction is in play here, which means that relative to the ground, the car actually the wheels are not moving. So the force applied would have to equal the force of friction, so that the overall net force would equal 0. By plugging in these numbers, I got the velocity equal 38.34 meters per second. This again makes sense, since the force applied equals the force of friction, so that it cancels out, because you need static friction is when relative to each other they're not moving. So if you are sliding, that means that you are moving in relative to the ground. You are no longer static friction, you're kinetic friction, and that is not good. So that's how I determined to solve this problem. Thank you.